Hello all, welcome to my YouTube channel. Today we shall do a hypothesis testing problem. Okay, let me read out the question first. The manufacturer of a certain brand claims that the mean lifetime of its product is more than 30 months. A sample of 50 gives a mean of 30.5 months. Population standard deviation is 1.5 months. Can we support the claim at 0.01 level of significance, that is 1% level of significance? So few things we need to understand first. This is a test for mean. Okay, so this is the first part. Second point is that sample size n is 50, okay, which is considered to be a large sample because sample size greater than 30 is considered to be large, and also population standard deviation is given, that is sigma is given, that is 1.5. So this is a test for mean for a large sample where population standard deviation is given. So the most appropriate test will be Z test for mean. Okay, so we shall do this hypothesis testing problem in two ways. First, I will do it in conventional method where I shall find out the critical value and compare the test statistic with the critical value, and then next I will do it with p-value approach. Okay, so now hypothesis testing problem has few steps. Okay, so we shall start with the step 1. Step 1 is setting up the null and alternative hypothesis. The null hypothesis denoted by H naught is called the hypothesis of no difference. That is, here we shall state that mu is not different from 30. So mu equal to 30 is our null hypothesis. Alternative hypothesis denoted by HA or H1, okay, which is the claim in this problem. Note that alternative hypothesis is not always the claim. The null hypothesis may be the claim. This is based on the problem. Okay, so the claim is mean lifetime of the product is more than 30 months. So more than 30 months. So that is the alternative hypothesis. So from null and alternative hypothesis, we find out the type of hypothesis test it is. We have two types of hypothesis test, one tail or two tail. Okay, so we can see that the alternative hypothesis has this greater than sign. Okay, so one tail, these are called all one directional alternative hypothesis. So test will be one tailed. If the alternative hypothesis has not equal to sign, then this is called a two tail test. Okay, so we have one tail test, but which one tail? Since it is greater than sign, so this is a right tailed test. Okay, now we go to step 2. Step 2 is finding out the value of the test statistic. We know that this is a Z test for mean. So the formula for the test statistic will be Z equal to x bar minus mu divided by sigma by square root of n. Okay, x bar is the sample mean from the question, it is 30.5 minus the hypothetical mean mu divided by sigma 1.5 and square root of n, that is 50. Okay, we find out the value to be 2.36. Okay, so the value of test statistic is 2.36. Now we go to step 3 where we compare the value with the critical region. Okay, so now step 3 is the decision rule. We know that alpha is given to be 0.01 and this is a right tail test. That means the critical region will be at the right tail. So this is 0.01, that is our alpha and the critical region, and this is 2.33. We get this value from the Z table. Z.01 is 2.33. That is for 1% level of significance, the critical value of Z is 2.33. We get this value from normal table. If you want to understand how to get this value, you can watch my video of critical values. Okay, so critical value of z is 2.33. So the decision rule will be reject the null hypothesis if z greater than 2.33. That means if the value of test statistic is greater than 2.33, we reject the null hypothesis. If it is less than 2.33, we fail to reject. So this region is called acceptance region, and this region is called critical region or rejection region. Okay, now we go to step 4. Step 4 is the decision. That is, we compare the value of test statistic, which was 2.36, with the critical value. We can see that 2.36 is greater than 2.33. That means the value of test statistic will be somewhere here. So it is in the critical region. Therefore, we reject the null hypothesis. So our decision is to reject H naught. Then final step, that is conclusion. So we conclude that there is sufficient evidence to support the claim. What was our claim? Mu greater than 30. Since we reject H naught, that is, we reject mu greater than 30, so we conclude that mu greater than 30, that is, there is sufficient evidence to support the claim that mu greater than 30. Now we shall go to p-value approach. In p-value approach, the step 1 and step 2 are same, that is, we set up the null and alternative hypothesis, and then we calculate the value of test statistic, and the third step will be calculating the p-value. So step 3 is calculating the p-value. So p-value for right tail test will be probability z greater than 2.36. 2.36 is our test value of test statistics. So p-value is calculated with the help of test statistics. So 2.36, and we have to find out this value. So that is our p-value. Note that since this is right tail test, p-value will be at the right tail. If this was left tail test, then the p-value would have been this one in the left side, and the formula would have been probability z greater than whatever value of the test statistic is. And if it is a two-tail test, then p-value would have been at the both tail, that is two tail of the z curve, and the formula for p-value would have been probability mod of z greater than whatever be the value of test statistic. So since this is a right tail test, we find out probability z greater than 2.36. Using the z table, this is 0.0091. Now step 4 is the decision. Okay, and the decision is based on the alpha and p-value. So what we do, we compare p-value with alpha. We can clearly see that p-value is 0.0091, which is less than, slightly less than, but it is less than 0.01, that is alpha. And if p-value is less than alpha, we reject the null hypothesis. So this thing you clearly note down that in p-value approach, we compare the p-value with alpha, okay, the level of significance, and whenever p-value is less than alpha, we reject the null hypothesis. And then we go to the final step, that is step 5. Step 5 is the conclusion. There is sufficient evidence to support the claim. Okay. Now one more thing I need to tell you, that we compare p-value with alpha, and sometimes in the question alpha is not given. So what we do, after we calculate the p-value, we compare it with 0.05, that is the standard level of significance. Okay, and if p-value is less than 0.05, we reject H naught. If p-value is greater than 0.05, we fail to reject. Okay, this we do when p-value alpha is not given in the question. Okay, then we take the standard alpha, that is alpha equal to 0.05. Okay, welcome again. Now the question is, the manufacturer of a certain brand claims that the mean lifetime of its product is at least 30 months. A sample of 50 gives mean of 29.5 months. Population standard deviation is given to be 1.5 months. Can we support the claim at 0.01 level of significance? So the first step is setting up the null and alternative hypothesis. The null hypothesis, denoted by H naught, we know that it is the hypothesis of no difference. So we take mu equal to okay. Now what is the claim? The mean lifetime is product is at least 30 months. That means greater than equal to 30 months. So we take mu greater than equal to 30 as the null hypothesis. Okay, and the alternative hypothesis is mu less than 30. See, null hypothesis can have greater than sign, considering we have greater than equal to sign. Since it is at least 30, so we consider this as null hypothesis. So for this particular type of problem, the null hypothesis is the claim. Okay, now we find out what type of test it is, one-tailed or two-tailed. So that is based on the alternative hypothesis. See, the alternative hypothesis has less than sign, that means it is a left directional, okay, left directional alternative hypothesis. So the test is left tail test. Okay. Now we find out the value of test statistic. So test statistic is z equal to x bar minus mu divided by sigma by square root of n. X bar is the sample mean, which is given to be 29.5 minus 30 divided by 1.5 divided by square root of 50, the value of which is negative 2.36. Now we go to step 3. Step 3 is the decision rule. Now alpha is given to be 0.01 and this is a left tail test. That means the rejection region will be at the left tail of the Z curve. Now from standard normal table, this is negative minus negative 2.33, the critical value of Z. So Z 0.01 is negative 2.33. So we now can find out the decision rule. Okay, since this is a left tail test, the decision rule will be reject H naught if the value of test statistic is in the left side of the critical value, that is Z less than negative 2.33. Now what is the value of test statistic? Negative 2.36. So we go to step 4 and we can see that negative 2.36 is less than negative 2.33 because 2.36 will be somewhere here. So negative 2.36 here, it is in the critical region. So what is our decision? We reject the null hypothesis. Now I go to final step, that is step 5, conclusion. So what we do? We reject the null hypothesis, which is mu greater than equal to 30, which was our claim. So there we actually rejected the claim. So our conclusion will be there is sufficient evidence to reject the claim. Okay, not support. In earlier question it was support the claim and here it is reject the claim. Step 3, now we go to p-value method. Okay, in p-value method step 1 and step 2 are same and step 3 is p-value, finding out the p-value. Okay, so since this is a left tail test, p-value will be the at the left tail of the Z curve, that is p-value Z less than minus 2.36, Z less than negative 2.36. So this is our p-value. Okay, from Z table we find that this is 0.0091. Okay, we go to step 4, that is decision. Now whether it is a right tail or left tail or two tail test, our decision using p-value is always same. That is, we see that whether p-value is less than alpha. If p-value is less than alpha, we reject the null hypothesis. So this is our decision, and step 5 is the final conclusion. So there is sufficient evidence to reject the claim that mu greater than equal to 30. Okay, hope you understand the test I have explained. Okay, thank you for watching. Welcome again. Now let us understand how we find out the p-value from Z table. So as you remember, the p-value formula was probability Z less than negative 2.36. Okay, so from this Z table we find out the value probability Z less than negative 2.36, that is area to the left of negative 2.36. That is why we choose this table, standard normal distribution table, area to the left of Z score. Okay, so from this Z we find out the value negative 2.3. This is negative 2.3, and from the column we find out 0.06. So that will be our negative 2.3 and plus 0.06, so negative 2.36. So intersecting cell of these two is 0.00914. This is the area to the left of negative 2.36. That is, probability Z less than negative 2.36 is 0.00914 or 0.0091. Again, this probability is same as probability Z greater than 2.36, because Z curve is a symmetrical curve. It is symmetrical about 0. So whatever area is to the left, same area will be to the right. Hope you understand how we find out the p-value from this Z table. Okay, thank you for watching.